You're listening to an article by Eminent, an expert in aerospace engineering and technical consultation. See us at eminent-design.com. In the aerospace industry, equipment on board an aircraft faces rapid and extreme temperature changes as the aircraft climbs, descends, and operates in varying climates. RTCA DO 160. Section 5. Temperature Variation Testing addresses this challenge by evaluating how airborne equipment withstands temperature fluctuations and thermal cycling. Temperature changes can cause material expansion, contraction, and stress, which can lead to equipment failure if not properly tested and prepared. Here, we'll explore Section 5 in depth, covering its categories, common failures, mitigation techniques, and why it's essential for airworthiness and flight safety. The importance of RTCA. DU 160 Section 5 for flight safety and airworthiness. Aircraft equipment must be able to endure sudden shifts in temperature, which occur naturally during flight operations. From cruising altitudes where temperatures plummet to rapid heating upon descent, equipment must continue functioning without performance degradation. Section 5 of DO 160 ensures that airborne systems can withstand these shifts, maintaining reliability and safety standards necessary for airworthiness. Key categories of temperature variation testing. Section 5 of DO 160 includes multiple categories of testing to simulate different temperature fluctuation rates and ranges that equipment may encounter. FAA guidelines and customer-specific requirements help determine the appropriate testing category for each piece of equipment, depending on its operational role and location. Category S2. The standard category exposes equipment to moderate temperature cycles to simulate typical flight conditions. Common failures include cracks in solder joints and stress on mechanical parts due to expansion and contraction. Mitigation. Employing flexible mounting systems and using high-temperature solder can reduce the impact of thermal cycling on critical connections. Category AR. Designed for extreme conditions, Category R tests simulate rapid temperature changes to replicate fast transitions between cold and hot environments. Failures often include structural fractures or material degradation from thermal stress. Mitigation. Using materials with low thermal expansion rates and adding thermal insulation around sensitive components can prevent fractures. Category T. Category T tests focus on equipment exposed to both high humidity and temperature variations, as found in certain unpressurized areas of the aircraft. Failures commonly include moisture condensation on circuit boards, which can lead to corrosion or short circuits. Mitigation. Conformal coatings on electronics and moisture-resistant seals help prevent condensation and protect internal components. Category A. This category simulates prolonged exposure to extreme temperatures, assessing equipment durability over extended periods. Failures may involve material fatigue or delamination under repeated stress. Mitigation. Selecting fatigue-resistant materials and reinforcing connections can extend equipment lifespan and prevent delamination. Typical failures in temperature variation testing and their mitigations. Temperature variation testing often exposes specific failure points in equipment, particularly in systems that rely on stability and integrity to function effectively. Thermal expansion, leading to cracking. Repeated temperature shifts cause components to expand and contract, which can lead to cracking, especially in metal and plastic materials. Mitigation. Using materials with low thermal expansion coefficients and stress relief designs helps reduce cracking risks. Condensation and corrosion. Rapid shifts between cold and warm temperatures may lead to condensation on electronic circuits, causing corrosion over time. Mitigation. Applying conformal coatings to protect electronic components and designing sealed enclosures prevent moisture ingress. Insulation. Breakdown. Insulation materials can degrade under continuous temperature cycling, leading to short circuits and reduced performance. Mitigation. Using high-quality, temperature-resistant insulation materials enhances durability and ensures continued performance. Rationale behind temperature variation testing. Temperature variation testing under DO 160. Section 5 verifies that equipment can endure the stress of rapid and repeated temperature changes. Such resilience is vital for maintaining equipment functionality, especially in unpressurized areas where temperature swings are more extreme. FAA standards and customer specifications determine the testing category, ensuring equipment aligns with its intended operational environment. By identifying and addressing these vulnerabilities, Section 5 testing enhances safety, reduces maintenance needs, and supports airworthiness. Consulting for RTCA DO 160 Section 5 testing. How Eminent can support your certification needs. At Eminent, our consulting team specializes in DO 160 Section 5 testing requirements. We provide support throughout the design process to help prevent common temperature-related failures, as well as solutions for challenges that arise during testing. If your equipment encounters issues with temperature variation compliance, we can help you meet certification standards and ensure your product is ready for airborne applications. Thank you for listening. Please check out our articles on other DO 160 sections.